Welcome to Lesson 19, Exponent Rules. So, these are some pictures from my week. You will need a pencil and paper or your computer to take notes. Oh, man, it's pretty hot. Did you guys get hot? Hello? Peekaboo! My kids are really enjoying peekaboo. Okay, let's get started. Today, you want to title your notes Exponent Rules. It may seem like it's just like, well, we've done exponents, but now it's like talking about powers and that kind of stuff. So your objective is I can simplify expressions using the properties of exponents. Some important thing that you're going to need is this vocabulary term, which is power. That's just another word for exponent. Okay, so there are 4 parts to this video, so it is going to be a bit long. But you can always walk away and come back. Now, with this, it's really important you take notes. They're not going to be hard notes. They're not going to be long notes. But I still have to revert back to my notes to remember what I'm supposed to do. It's like, unless you're doing it consecutively a lot in a row, you tend to forget these kind of things. So make sure you take notes on this video. Okay, so part 1 is negative and zero exponents. So negative exponents. If you have an exponent that is negative, so for an example, in this picture here, we have x to the negative a. Now, we can write this as a positive exponent by just putting it under 1. So we just put the same number, take away the negative, and put a 1 over it. Same thing, if you have a fraction, and it's on the bottom of your fraction, take away the negative and put this on the top. So you would have x to the a times 1, which gives you x to the a. All right. So in fancy words, if a negative exponent is in the numerator, then move it down to the denominator and it becomes positive. Over here, if a negative exponent is in the denominator, it moves to the numerator and becomes positive. So, for example, if I have 3 squared, well, we know 3 squared is 3 times 3, which gives us 9, right? 3 to the power of 1 is 3. There's just one 3. 3 to the power of 0, that is going to be 1. Anything raised to the power of 0 is 1. 3 to the negative 1, remember how this was 3? Up here is 3, so then we're just going to put it over 1. Right here, well, this would be 1 over 3 squared. What about this one? 1 over 3 to the power of 3. All right. What about zero exponents? I briefly mentioned how any number raised to a power of 0 is always 1. Well, not always. So 4 to the power of 0 is 1. W to the power of 0 is 1. 3d raised to the power of 0 is 1. 9x squared y to the power of 0 is 1. You're getting this pattern? But watch out. If you have a negative in front of it, then it's going to be a negative, because this is basically saying, hey, I have negative 1 times 7 to the power of 0, which if 7 to the power of 0 is 1, 1 times negative 1, we have a negative times a positive, which gives me negative 1. Okay? Same dealio here. Let's try to rewrite these expressions with positive exponents. So, just like we did in the example previously, we're going to take away this negative and put it over 1. So we're going to rewrite this as 1 over 3 squared. What about this one? Well, It's on the bottom, so we want to move it up to the top and take away the negative. We're just going to do it as z to the 9th. Okay, what happens here? Well, this one's already positive, so we just want to move this part to a positive. So how do we do that? We have, well, if I can separate this, and this is y to the 7th times 1 over y to negative 2, which turns into, I don't have any room, so we're going to erase that. So y to the 7th, and we're just going to move this y squared up top. So that is an expression with positive. Now we can get a little bit further, which we'll talk about later. All right, right here, we have 2x raised to the power of negative 15. So this is actually going to be 2 over x to the 15th power. Okay, so we have to be careful. This 2 is not part of this exponent. Well, what happens if the 2x is inside of the parentheses here? Well, then we would put all of it under 1 because of these parentheses. All right, right here, 8 divided by 2 to the negative 2, well, this would be 8 times 2 squared. And then you could go further and say, hey, 2 squared is 4, so I have 8 times 4, which gives me 32. So if we weren't to evaluate these, which we don't have to. Okay, and then finally here, we have a negative on top, so this is just going to go down to the bottom, and this one's going to go to the top, so we're just flip-flopping them. So we're going to write this as 9 to the 7th over 9 to the 3rd. Okay, so let's reiterate. Okay, so if I were to write this with numbers, say I have x to the negative 2, well then I could write that as 1 over x squared to make that exponent positive. It's just moving it down to the numerator. Well, what if we have 1 over x to the negative 2? Well, we just flip them. It's the reciprocal. So we have x squared over 1, but we don't need this 1, so we erase these two. Okay, that's it for part 1. Now we're starting on part 2. How do we multiply powers? So if I have some work like this, where I'm doing 3 to the 4th times 3 to the 5th, how can I simplify that? Well, let's think about what this means. 3 to the 4th means that I have 3 4s. 3 times 3 times 3 times 3, right? And then 3 to the 5th means I have 5 3s. So 1, 2, 3, 4, 5. How many 3s do I have in all? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So when you're multiplying numbers, the base always stays the same. So when we're multiplying powers, and when we're talking about multiplying powers, we're multiplying the exponent piece. So, and the base stays the same. But instead of multiplying, what we're actually doing is we're adding. So hopefully you guys noticed that we just did 4 plus 5 to get 9. So this is right in your notes. When you multiply powers with the same base, it only works if base is the same, then you add their exponents. So this only worked because, didn't mean to do that. It only worked because we had 3's. They were the same number. Okay, so that's what we do when we multiply. Let's try some more. Okay, now, right here, I have 7 to the negative 6 times 7. What's going to be there? Well, what's the exponent? Our exponent is actually going to be 1 right here. So how do we get this? So this really means 7, and we have negative 6 plus 1. So this one's going to be 7. And what's negative 6 plus 1? Negative 5. So that's how we can rewrite it. Now, if we wanted to write it with just positives, it would be 1 over 7 to the 5th. So either one of those would work. You would just have to make sure. Does it ask you if it has to be positive? Then you would write it as a fraction. If it's fine having a negative exponent, then you can write it 7 to the negative 5th. Okay, let's try another one. Right here, my base is the same, negative 10 and negative 10. So then that means I have negative 10 as my base. It's always going to be the same base. And now, since it's multiplying, then I'm going to do 8 plus 5. So I have negative 10 to the power of 8 plus 8, 9, 10, 11, 12, 13. Okay, so these are pretty easy. We just have to remember what the rule is, and that's why you need to write it down. Okay, let's try some more. Why don't you pause this video, you try it, and then come back to me. Okay, same base. So now we're going to do 3, and then 3 plus 2 to get 3 to the 5th power. Now, even though we're multiplying here, a lot of times you want to multiply and get 3 times 2 is 6. We're not multiplying. When you're multiplying these, you're actually adding. So that's why you need to make sure you have your good notes. Okay, right here, 6 to the power of 1. So now we have 6 with 1 plus 7, which gives us 6 to the power of 8. Okay. Okay, so think about it. We have 1 6 here, and then we have 7 6s. So how many do we have in all? We have 8 6s. Okay, all right. Part 3, dividing powers. So let's figure out, what are we doing here? Right here, this is the same thing as having 5 4s. Okay, now on the bottom, I have 2 4s. So the idea behind this is I am taking pairs and I'm eliminating them. So I can eliminate a 4 divided by 4. I can eliminate a 4 divided by 4. What do I have left? I have 3 4s on top. Okay? So I have 4 to the 3rd power. What did I end up doing? Well, I did 5 minus 2. So I actually took the exponents and I subtracted them. So the rule for dividing powers is, as long as it has the same base, you subtract their exponents. Okay, pause it if you need to take these notes. Well, and I would suggest that you write these down. Obviously, I can't see what you're doing until you take a picture of the notes. Make sure you write this down, because you're going to be able to use your notes on your quiz on Friday. Okay, let's try some examples. Ooh, here, I added something for you. I actually added in a negative. So let's try this. I'm going to take 5 as my base. I'm doing 7. Oh, guys. 7 minus negative 4. Okay? So I'm actually subtracting a negative. So if you guys remember, we're going to keep change. So this is actually 5 to the 11th power. Okay? So what does that actually look like? Like, why does that work? Because remember, 5 to the negative 4th can be rewritten as 1 over, oh, I'm sorry. Let's start that over again. This here is 5 to the 7th over 1 times 1 over 5 to the negative 4. So 5 to the negative 4 is on the bottom. So we can put this on the top by making it positive. So I actually have 5 to the 7th and 5 to the 4th, which means they're multiplying, and then we can add. Now, if you don't want to remember this bit, you don't have to. You can ignore everything I said about that. Okay? As long as you are subtracting and making sure that you're not ignoring the signs. Okay, let's try this next one. We have 8/9 over 8. So how many 8s are here? There's 1. So this turns into 8. 9 minus 1. How many 8s do we have? We have 8. Right? So if I were to write this out in expanded form, what would that look like? Well, I have 9 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many 8s do I have on the bottom? I have 1. So I can cross out a pair. I can cross this one and this one out. How many 8s do I have left? I have 8. Let's do some more. So this is the same thing as 5 10s. 1, 2, 3, 4, 5 over how many? 3. 1, 2, 3. Cross out my pairs. How many do I have left? 10 over 2, which, if you guys use the rule, I could have just said, hey, 10, 5 minus 3. Well, that gives me 10 squared. Okay, let's try this one. I would have 1, it's my same base, 11 minus 3. Well, what does that give me? 1 to the 8th power. Or guys, it's a base of 1, so it's just going to be 1. All right, let's try something else. Say I have a base of 5, and I have 5 to the 2 over 5 to the 6th. Well, I can take 5 and 2 minus 6, and I get 5, 2 minus 6. That gives me negative 4. So I could write it as that, or I could do 1 over 5/4. Generally speaking, they want you to write it as a positive. So what I like to think of is I'm subtracting them. 6 minus 2, that gives me 4. But the 6 is bigger, so my answer is actually, my final thing is always going to be on the bottom. So that's a way to think about it. Okay, part 4, monomials. What are monomials? A number, a variable, or the product of a number and variables. Basically, it's something that's one term. So all of these examples in the black box are one term, even though they have more than one variable. A to the 4th power times b, that's one term because there's not a plus or minus between them. Okay, so if you guys remember way back to creating equivalent expressions, the terms were separated by a plus or minus. So we can apply these rules that we talked about to monomials. I don't know if I'm saying that right, but it is what it is. So here we have y to the 4th times y. Well, since we're multiplying, that means that I can add them to get y to the 5th. So we can simplify these using our power properties that we just talked about. Oh, this one here looks really complicated, but look what I did. I rewrote it so that my constants are together, and then my exponents are multiplying too. So that means I'm adding. And then this was my simplified monomial. So let's try some. So first step, we want to rearrange the factors. What does that mean? Well, it means that I'm taking my constants. All of this together, guys, is multiplying. So I'm doing 2 times 4 times, okay, so my multiplication is going away. So I'm going to use a little red X. S squared times S to the 4th. So I've just rewritten it. Now I'm going to multiply my constants. So 2 times 4 gives me 8. And then here I have multiplying my variables. But remember, when you're multiplying the exponents, the powers, you're actually adding them. So I'm going to add, oh, sorry guys. I'm going to add 2 plus 4. So I have S, 2 plus 4, which simplified gives me 8. S, 2 plus 4 is 6. So that's my final answer right there. What about if we divide monomials? Well, it's the same process that we were talking about because the base is the same. That H is the same on the top and same on the bottom, which means that we can subtract them, right? So think about your monomial rules. We can subtract them. So 12 minus 5 is 7. So our answer is H to the 7th power. Okay, what about this one? Okay, remember, we're going to look at our constants first. And we can simplify that. 16 divided by 4, well, that gives me 4. Okay? And then I'm subtracting, since I'm dividing, I'm subtracting the 7 and the 15 to get this. Now we could rewrite this so it's positive, right? That would be 4. 4, oh my, come on. 4 over x to the 8th. Okay, so we could write that both ways. All right, now let's try some. These are a little bit more complicated. Expand the problem. That means I'm going to rewrite it in a different way. So I have 8 over 14, and then I have my x's of 9 minus 3. So if I simplify that, 8 over 14 can be simplified down to 4/7. And then 9 minus 3 gives me 6. So when I divide my variables, it means that I'm subtracting my exponents. Okay, let's try the ones with C. I need to expand the problem. 5 over 13, and then I have C is 9 minus 14. Well, that gives me 5 over 13 can't be simplified. And then 9 minus 14, that gives me C to the minus 5, because 9 is smaller. Now, we can rewrite this so that it's positive as 5 over 13c to the power of 5. Okay? All right, let's do a challenge problem. We could have a power to a power. So for example, in this, we have 3x squared, and we're raising all of this to the power of 4. That means that I have 4 of this term. And I'm going to use a different color for my times because it's an X. I would do a dot, but it keeps on erasing it. So I'm using green as my multiplication. Okay, maybe I'll just do a really big dot. So if I think about this, I have 3 of these that I'm adding. I just messed up. I'm just talking about all of this multiplication sign when it's actually adding. So 3 plus 3 plus 3 plus 3, that's 3 to the 4th, right? So this is really, we can take a power to an exponent. We can multiply the exponents. So in this case, we're actually multiplying it, right? So I have 3 to the 4th, and then 4 times 2. So 3 to the 4th would be 12, and then I have 8 power of 8, right? Because 2 times 4 is 8. So let's try some challenge ones. So we can multiply these. Power to the power. Think about, like, when I think about these rules, I'm like, okay, when we multiply, then that's going to be adding. So multiplying and adding are always my favorite operations out of the 4. And then dividing and subtracting go together because I hate those. And then the exponents are like, ooh, and a little extra. So we have to apply this to all of the things inside. So 2 cubed. Then we have x squared and 3. 3 times 2 is 6. And now we have y. 3 times 3 is 9. So that's my final answer right there. Now, we could simplify that. 2 cubed. So 8. But we'll probably keep it as the cube. All right, let's try this one. Okay, so we need to multiply these, kind of like the distributive property, guys. We have to distribute the exponent to all of them. Okay, don't forget about the constant. We have 6 squared. Then we have a 2 times -4, that gives me -8. And 2 times 10 gives me b to the 20th. So that's my final answer right there. All right. I know this was long, but each of those should be pretty simple. Not that they're easy, but they're simple as long as you have your notes that you can figure out, oh, I just have to multiply. Oh, I'm just adding or dividing. Okay, so submit a picture of your notes. I'll see you on Wednesday at 9 to do some more examples and to clarify some things because it seems really complicated, but once you break it down, if you're using your notes, it should be pretty simple. Okay, so ask me questions on Wednesday. I'd love to see you. Bye. So did I freak you guys out? Gotta. Don't know how to stop the video.